Yeah, so welcome back. I have, yeah. So I wanted to, so I've never done this talk at a Frappe conference. I did this talk at PyCon last year, and this was a talk I always wanted to do. So this is basically sharing the stories of how Frappe Framework came to be. And this is also a personal journey for me as somebody who started writing code at a very young age. So I'll talk more about that. Yeah, okay. We have a feedback. So I'm sure everybody here knows Frappe Framework. Anybody who doesn't know, it's a full stack web framework. It's Python and JavaScript. I've been building this since 2005. And the main goal for Frappe Framework, the first project we built on Frappe Framework was ERP Next. And this is like a brief introduction. I mean, those who are come for the first time never heard. Actually, the underlying power of ERP Next is essentially the framework, right? I'm sure you will discover it if you haven't. So I'll start with where I first encountered a computer. So this is in the year 1990. I was in class 5, and this is a BBC microcomputer. I don't expect anybody to have seen one of these. Nobody, right? Okay. Yeah, Danish Bhai is here. As well as Ganesh also here, having seen a BBC micro, yeah. So the backstory behind this is the BBC, which is the British Broadcasting Corporation, is a British state-run corporation which created this computer specially for educational use. And for some reason, I have no idea, that in my school, which is right here in Mumbai, Don Bosco, Matunga, they had these computers in the year 1990. And I don't know who was the visionary behind it, but this computer got connected to a television, and it ran BASIC. And this is my, so in class 5, I joined this. It was a summer course for maybe 4 weeks or something, where they talked about what is a computer, and then they talked directly programming. And for me, programming was like English. Like, I could read a program and instantly understand what it did, right? Nobody had to explain me what is a loop, what is a condition, what is a variable. It all felt very logical to me, because maybe BASIC was a language that was designed for kids like me, right? It was a beginners. I'm sure very few people would have even written code in BASIC. So it's beginners all-purpose symbolic instructional code, right? So I think it was the perfect place to start computing. Today, my 10-year-old is learning to program, and it is so horrible. Like, I don't know where to start programming, right? I mean, should I teach him CSS? Should I teach him JavaScript? Should I teach him Python? Like, because you can't run a program anywhere. But these were very self-contained machines. You could run a program and get an output. This is another machine. So again, I was lucky that I have a friend, Amit. He's in London now. But so his father was a hacker tinkerer. And he ran a shop. Like, if you've seen Mr. Robot, the TV series, anybody Mr. Robot fans? Yeah, some of you. So he ran a shop in 1990, which was exactly like Mr. Robot's shop. It is very uncanny, but it was a tinkerer's paradise. He had his ZX Spectrum machines, and again, basic programming. So these were Sinclair machines that you again connect to a television, and you could program. To store information, you had to use cassettes. I'm sure most of you haven't seen cassettes either, but these were, tapes that you stored your programs in. And this was again fun. I had great time growing up, with my friend. We used to build programs just for fun, making games. So this is a computer that I had at my house. This is not the exact photo, but this is a replica or similar kind of a computer, which was like an old bank computer that got replaced and somehow found its way in my home in 1992 or 93. This had no graphics. It had only text, and it was a green phosphor monitor. And obviously there are no colors other than the green that you see. And it had only an ASCII display. It had 640 KB of memory. It had 10 MB hard disk, which was supposed to be like, it was insane, like 10 MB of hard disk. And these days you can't fit a photo in 10 MB. But and yeah, it had a mouse though. That was the interesting thing. It had a mouse. And what I did was, I knew BASIC, but then I had this computer, and I said, like, what more can I do with it, right? So there is this Union bookstore at Dadar station. I hope it is still there. So that's the only place you could go to buy books on computer. And I guess I picked up Peter Norton's assembly language guide for the IBM PC. Again, I had no clue what is assembly language, right? So, but it was a book and it looked nice. It had programs I could replicate on my PC. And so I started writing assembly programs. Again, school kid, no community, no internet, I can't go anywhere. So take a book, write some program, see if it works. Yeah, that's the book. And so this is another book I learned a lot from, this high resolution computer graphics using Fortran. I picked up this book from the British Council Library in Bombay. And it had 3D computer graphics programs, which were in Fortran, but I didn't have any Fortran compiler or anything. So I used to translate them to BASIC or whatever language I was writing in. So yeah, so this was the book. And yeah, some of the first programs I wrote were these, a mouse pointer. Like I said, it was an ASCII machine. And what I discovered, so assembly language instantly takes you under the hood of how the memory and the CPU and how instructions get executed and how many memory gets manipulated and how you can manipulate devices like your screen display. And so I wanted to make a mouse pointer because I'd seen fancy Windows computers with my friends that I didn't have any Windows running. I also built, so again, I don't know if I have a mouse. Yeah, so a mouse pointer is essentially you have to, so I didn't know how, there was no API, right? There is no API for a mouse, and there is something called interrupts is what I heard. And I remember, you move a mouse and it will throw you an interrupt 121 or 122 or 123, depending on, which direction. I think there are 8 directions you can go in. And based on that number, you figure out like where you want to move your pointer to. So you want to move it top, top left, top right, all of that. And then you copy the pixels underneath the mouse, and then you store it somewhere, and then you draw this pointer. And when it moves, you kind of restore some of the pixels. Very basic stuff. No, I mean it's, but getting this gave me a lot of confidence. Like I was very happy to make this mouse pointer. It really, it's something that gives you joy, right? Instant kick. Oh wow, I got this working, right? So some other programs, like I'd said, was a word processor. Like I'd seen this fancy word processors in Windows, and I started writing my own. I made all the menus, you click and you get a drop down menu and you select, mouse hovering, all of that. This is like before CSS, still doing the same thing. But, and then finally, I could get some typography going, some text you could write. And then finally, like after like a lot of effort, I got this whole thing running, and I reached the end of the page and I realized I can't scroll. So at that point, that program was so broken that I said, no, that's where it ended for me. Again, this 3D scene rendering, this is where you got into doing like hard math puzzles to render a screen in 3-dimensional. So again, learned mostly from books, copying programs. Yeah, this is the kind of programs that I wrote to, you render all the vectors, all the points, surfaces, you define them in code, and then, screen renders, there is a perspective, there is a, there is a light coming in from somewhere, there is overlapping planes that, some is in the front, some is in the back, you have to intersect them, right? So a lot of interesting hard problems. So another thing I got introduced to during this time was, reading a lot of science fiction books. Michael Crichton was my favorite when I was in school. Jurassic Park was out in 95, I think. So very inspired by all this American tech world that was somewhere out there, right? We had only access to books and television and stuff like that. Then interestingly, a cousin of mine was running a single person software company. It was a software product company. And that product was basically, it's called profile nesting. So you have a sheet and you have to cut it into smaller pieces, and what's the most optimum layout is what the program will tell you. So I used to intern with my cousin, and it was an amazing experience. We used to do pair programming. Like I've never heard of this term pair programming before, but it really worked for us. Like one of us used to walk around and do the math, and the other person used to write the code. And that was a lot of fun. I mean, so doing this, we had, again, there are various approaches you can solve them, but underlying you need an engine. So you can do vector math, right? So when you have weird shapes, you can't put these shapes into some equations that you can solve for intersection and stuff like that. So we we moved to a bitmap style system. A bitmap is basically you create like a, a, a two-dimensional representation in pixels, right? And we did some really cool hacking there in Visual Basic. This was VB6, I remember. And then I went to the US, and this is where that's Penn State University logo. And I was part of a lab of supply chain planning and engineering. And what I got fascinated there was building simulators. So a lot of the research that happens in supply chain is, how do you optimize inventories and how do you optimize lead times and all of that. But then can you model, so you could model a single factory with warehouses and materials going in and out, but can you model an entire supply chain? So I built a simulator, and this is where my object thinking became very strong, because there was like an entire hierarchy of objects, right? If you can see, there is like factories, and then there is a sales department which creates a sales order. Now where all this ERP next, learning comes from. And then your workstations, like whatever, right? And then you have planning, right? You have your sales planning coming in. So this entire system was modeled. I built this right from scratch in, again, Visual Basic or Visual Basic.net, I don't remember. And then it used to run simulations with different configurations, different rules for buying, selling. Yeah. So every time I got a chance, I used to do programming, right? Any project, for somebody like, if you're a hammer, everything is a nail. So for me, everything was a computer program. That every problem was an opportunity to write a computer program to solve it. Then I learned Basic. I started with Basic. These were my languages, Quick Basic, Visual Basic. And then in the same lab, I was asked to do a project in Java. This is again very object-based system. I hated Java. I hated NetBeans. I hated Eclipse. It used to take like 3 minutes to boot up, Eclipse, just to get Eclipse started. It was so horrible. But somehow I got into another interesting thing happened, right? This is in 2003. There was a different Web3 going on. Now we have something called Web3 that was going, but in 2003 there was another Web3, and that Web3 was semantic web. And this is Tim Berners-Lee, who is the inventor of World Wide Web. And he was behind this new Web3 project. And the idea behind Web3 is that the way we share information on the internet is by HTML, right? That's the standard format of information. And HTML is essentially telling you about how your data looks like. Okay, this is a heading, this is a paragraph, this is a table, whatever. It doesn't tell you what the data is. Like, it doesn't tell you this is an address, this is a name, this is a product, or this is a person. And Tim Berners-Lee realized, that this standard could have been so much better if instead of just showing how to display information on the web, if we could also tell what the information meant. And there was this thing called semantic web that was being proposed, and there were some standards called RDF and OWL. Anybody here? Yeah, maybe somebody. But yeah, so it died, right? These web standard died because Facebook happened, and the whole internet became the walled garden. It was no longer thousands and thousands of web pages, people publishing information, but all the information got stored in platforms like Facebook and all of those. So these were standards that were published during that time. So resource description framework and web ontology language. This is what probably it looks like, right? So this was what the web was supposed to be, the web 3.0, that you could have a geo latitude, geo longitude. There could be some description and stuff like that. I mean, you can make out. So yeah, this is, we are still there, we're still talking about trust, we are still talking about all these things, but so what is an ontology, right? An ontology is a unified way of describing a system. And this is what I learned, like you could define any system using an ontology. Like if you knew the grammar behind expressing something, you could describe a very complex system. And then, so the heart of an ontology is two things, one is entities and relationships. You can call them objects and messages or whatever, but so you have entities and they have relationships. Okay, might take a minute or two longer. And then there are these assertions. So assertions are subject, relationship, and object. So how are two objects, how are two entities related is through an assertion, which is just a statement. So all you need is, something, Okay, all you need is that, so the base object is a thing. So everything is obviously a thing. So a place is a thing, a person is a thing. And then, if Mumbai is a place and, Rushabh is a person and, Rushabh is in Mumbai, right? So you can describe an entire system using just these assertions. They are called tuples. And this is one, I randomly went to this conference. It was in Maryland in the National Institute of Health. The place they were using these ontologies was in health informatics, because the human body is very complex and you are constantly discovering new and new relationships inside the human body. And the use where they found like a strong use of ontologies is in bioinformatics. And so this is a project from Stanford University, and this is a UI. This is the first time I saw this entire thing, right? So you have these objects, like, thing, right? Everything comes from a thing, and then there is ice cream and pizza, and there are different, like, this is classes basically, right? And then you have assertions that, what this pizza has, what toppings. But this entire thing is using this very simple entity relationship model. You could describe a very complex system and then you could visualize it. And that was also very interesting to me. In this conference, very interesting thing happened was I was sitting in a hall like this, and this thing was written in Java, and the project manager was giving a nice speech, and like one person put their hand up and said, "Is this in Python?" And this guy cringed. He said, "No, Python, I don't want to ever hear about Python," and something. And I was curious, like, what is this Python, right? And then I looked up what is Python. And yeah, Python for me was, again, because I came from basic, it was kind of love at first sight, no brackets, very elegant, readable code. I just fell in love with Python. And that point, I got a sense, okay, if I want to write programs, I want to write them in Python. 2004, Gmail happened. The whole paradigm for application development changed after Gmail. I don't know if people remember, but there was this whole class of thing called web applications that we take for granted today, didn't exist before 2004. Everybody was writing Visual Basic applications on some kind of a desktop machine. And this is where, Ajax got introduced. Ajax is running a web request inside a web page. And it seems like a really simple thing, but like nobody had figured it out until the Gmail people really built an application that was amazing. Like people couldn't believe, like, how can a web page load so fast? How can I click and instantly open an email? The whole page doesn't reload, right? Single page applications that we take for granted. Also, I got a iBook Mac. That was interesting thing. I was in university again in the US, and there are two labs. There's a Windows lab, there was the Mac lab, and Linux lab. There were three labs, and the Windows lab was always packed. So I had to go to a Linux lab or a Mac. And again, when I saw a Mac, it was like amazing. Again, haven't seen anything like a Mac before. And then I got one on student discount. Like, this is an iBook G4. It's a very 11-inch. So most of the framework is written on an 11-inch iBook G4. Yeah, so fast forward to 2005, I came back. I joined my family business. They were struggling from some ERP implementation. I think the condition was they had Tally running at office and in the factory, and there was a lot of synchronization issues. There was a Fox Pro based application that was being run for purchasing, I think, only purchasing on that. And the developer was absconding, and they were really, and there was a lot of paper going around, physical files being moved around. And I said, like, how hard can this be? Started writing ERP for that. Another thing, like I said, right, network software is something that was very new, because I had never written client server software. And like today we again take this for granted, but it is unnecessarily hard to write client server software. I mean, you have to write the client and the server. I mean, world used to be much simpler before that. So I had to find a right way to manage writing client server software. And the only web framework at that point in Python was Zope. This is what I could find from the Zope website. It's I don't think that project is being used anywhere. It was this is how Zope looked like. It was an object. It also had an object database along with it, and yeah, you couldn't support third-party databases. You had to write code in it was very restrictive in a lot of ways. And yeah, this is probably the first screenshot, the oldest screenshot I have of anything about the framework. This is what it looked like. I don't have the date, but maybe 2005. So it was running on Zope. I had a Zope admin panel open, and this is what the application looked like. Sales order. And then yeah, so the cloud in 2005 was cPanel, right? Now you go to host it, right? I mean, you can't get Zope hosting anywhere. I mean, there was just one Zope hosting provider during that time in Netherlands, but there was no Zope hosting. But you could get cheap cPanel hosting, and cPanel hosting meant that you could set up a one-click database. There was Frappe Cloud before Frappe Cloud, and you could do you can set up a database. You can run Python scripts. You can run simple Python scripts, and they had no way for you to run a process on the cPanel. So there's something called CGI Python. So CGI means every request fires up a Python command, and then whatever comes out of your standard output gets piped back to the screen. So it's just simple. Every request is a Python command, right? That is what CGI Python was. So after Zope, I rewrote the entire framework in CGI Python. I don't think this kind of codes exist anyways. So the idea there was, and this is where, I think Nabeen and I started building, where Nabeen entered the picture, and, we started building applications. And the idea was to build the entire app from the browser. Again, we don't realize how complicated the whole developer setup is today, right? I mean, you guys cry about bench setup. I mean, it's insane. Like the first version of framework, you could build entirely from the browser. You didn't need any other interface to write code. Server scripts and client scripts was how the entire code was written, right? There was, and then somehow this thing doctype was there, So the first versions of framework were RDF OWL compliant, which were the semantic, but then nobody was using it. So by 2005-06, I just said we call it doctype for some reason. The reason for doctype was that I think that name didn't mean anything in particular. So I said, okay, we'll call it doctype. I can't recall the reason behind why it is doctype. And like it basically had objects. The early version had just 2 tables. Like the entire database had 2 tables, objects and relationships. That's it. And like you could store an entire, everything, whether it's a sales order or a purchase order or a customer, everything is in one table. And then one day I ran a wrong update query and like everything without backups. One table is a bad idea. Anyway, so yeah, what is a doctype? Again, I won't belabor this too much. So basically doctype is properties, like, what module, what is the naming style, and then it has these. Another very interesting thing is because of this unique structure that we needed in an ERP system. Like in Protege, there was no concept of a child table. But we needed a child table for the sales order, right? You need order and order items. So child objects became first class in framework, which was, I think, very unusual. I don't think any kind of framework gives child objects as first class objects. So we have this child objects also, which has some, I think, we also have like a infinite recursion. I had made it, but I never merged that. But I haven't found a very strong use case of infinitely recursing child objects. But there is just one level of hierarchies baked into doctype. That has enabled a lot. I think that one small thing like makes it very different from any other admin panel out there. That you can have, your documents are not just static, like they have some vector objects as well. Yeah, it was low code before low code. I mean, there is a demo, but I'll skip because I'm already out of time. This demo was made by Hussein for PyCon. Thanks, Hussein. Kidhar hai kya? So what is framework? It's batteries included, does everything from handling your web requests. There's an ORM, does routing, templating, REST API, all of this, background jobs, roles and permissions, like insane number of features that got built over the years. Everything that was wanted for ERP Next. Notifications, attachments, prints, email, SMS, I think everything was that. Content management, website. You want to make a website, we'll build it on framework. Everything we want, we'll just build it on framework. So, there was no Ankush then to stop. And then this idea of metaprogramming, right? I mean, so the real fun in writing the framework is that you're not writing objects like a person or something, but you are writing a meta system which can handle any kind of object. So, this is what a basic, how do you define events in code? Like you just subclass it from document and everything else automatically, the system knows where to find it. Like, so when you do a Frappe get doc, it knows where to find it, right? So it's just this metaprogramming system. And Python, that's another thing. Like I didn't know this, but like if you've done I don't think Visual Basic had any metaprogramming. Java had, there's something called inspection in Java. Those who have done in Java, but it's very clunky. Like Python gave you inspection out of the box, right? I mean, you don't even need, like, if you do dot underscore underscore class, it will tell you what the class is. And you could do so much meta programming in Python, which was amazing. Again, luck, I didn't know that, Python was very good for meta programming. And yeah, you could do events. So another thing we did was use convention over configuration. Like most systems, like every entity has to, like you have to link it to another entity specifically. Like, I mean, you don't, it's not like you publish an entity and automatically it gets discovered by the world. But in the framework, like we've used conventions, like, you know exactly where, where the file is, where the folder is, you know how to extract an object, how to publish an object. Like these are all figured out for you. So the core API set, the core API calls you need to know is a very small subset. I think that is another thing that makes programming in the framework very highly productive. And this thing still blows my mind. I still remember when I was able to pull this off, that the doc type is a doc type. And I mean, there is no magic there. I mean, there are some if-else cases, if doc type equal to doc type, handle it this way, else handle it that way. But still, I mean, pulling this piece off felt really neat that somehow, we have got this right. For me, the reason why we built the entire framework, community, ERP Next on top of this is because maybe this one small decision, right? That a doc type is a doc type. It gave it this kind of robustness. The architecture became so robust because of this one small decision. And yeah, this still blows my mind. I mean, if there is anything that I remember. Yeah, so this is a doc type, it's defined using itself. It defines itself. Extensibility, and this is where I think Pratik Vyas came in. He's he's no longer there. I think like my history is self-taught. I have no idea what the world looks like. But then Pratik came, he understood Django. And so, he he created Bench, and then we had this whole extensible. I remember we having a lot of productive pair programming discussions, exploring how do we make the framework extensible, the idea of hooks, the idea of, running multiple apps, all of that. And the clean separation behind framework and ERP Next, right? I mean, there is, other than contact, I'm still very pissed about that. I don't think there is any leakage from ERP Next into the framework. So the framework is very clean, right? I mean, there is we had this clean thing, anything that is ERP Next can't be in the framework. So that also worked really well. Again, broad architecture of, multi-tenancy, that those are other more complex, sophisticated concepts that came in, I think, thanks to Pratik. I would give him credit. And then, yeah, everything that we built on framework, all of this. We have Frappe UI now. So this is the missing layer, the crafted UI is that, we talked about last time, we'll talk about it tomorrow. And, the new kind of applications we are building on framework, not using the framework front end, Raven and, third parties building, gives me a lot of excitement when people use the framework as a developer platform and Frappe Cloud Marketplace. Again, we have talked about this framework kind of now is in, I've been out of framework for the last 3 years. Ankush was driving it. But, the idea was to make it more stable, secure, performant. What I'm working on now for some time, because I really want to, explore and maybe see how, one thing we do badly is information hierarchy in framework. So I'm trying to fix that. It's a known problem for a long time, just haven't got to fix it. So now we have, the sidebars and other way, like how you discover information in framework is still hard. Like if you know the awesome bar, then you are set. But like for a new user, the information hierarchy isn't clear. So that is something trying to, maybe just quickly end with things that I learned during building. Like in engineering, the way we are taught, we are taught about data structures separately and we are taught about code separately, right? I mean, it's very, but like having first class data structures is also very important when you write code. And, it's like two dimensions, code which is dynamic and data structures which are static, come together somehow, in some conceptual sense. But we tend to forget. What framework got right was through doc types that data structures are first class. They are not like afterthoughts, or they don't get hidden inside the code, right? As dictionaries or objects. But this thing about having a unified language that can create a very complex system, like, like cells, like atoms, right? The whole world is made of atoms and molecules. They're very repeatable. Like if you blow up all of us, we'll get atoms and molecules. So the world, we get cells, right? So this whole idea that extremely complex systems are built with very simple core objects. And if you get those architecture of those core objects right, then you can build a very complex system. You have semantic integrity. This is one thing which was hard. I don't think we are 100% there. I would say we're 90% there. That everything has to mean the same. The doc type names, the variable names, the field names have to be consistent. And we've done a lot of renaming. I think you guys are spared, but we have renamed things like wild, mass search and replace. If this name doesn't feel right, just replace it in the code everywhere. I think we have maintained decent. I think that's why the framework code still feels very readable, because it maintains like a reasonably good amount of semantic integrity. And yeah, it's all 100% open source. Thank you. Hope I have not got over time.